Good afternoon, everyone. My name is Allie Cronick, and today's lab is going to be an introduction to the solar system. For this lab, you are going to need a pen or a pencil, a digital smartphone or a camera, a piece of graphing paper or an online graphing software, and a calculator. My phone will double as the calculator for this lab. Now let's get into the procedure. All right, let's get started. So the first step is to research the distance the following objects are from the sun in million kilometers and the amount of time they take to complete an orbit around the sun, which is the orbit duration in Earth days. So here I have already gathered this data for all of the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. On the left here, you will see the distance from the sun in million kilometers, and here you will see the data for the amount of time they take to complete an orbit around the sun in Earth days. This data will be recorded in data table 1, as you will see in the PowerPoint later. Continuing on, using the data that we have collected right here, we will be creating a scatter plot on this graph paper. We will be using the data in data table 1 to create a scatter plot graph of the distance from the sun versus the orbit duration on the graph paper using the following guidelines. The limits of the horizontal x-axis, which is right here, let's move this out of the way, which is right here, will range from 0 to 12,000 million kilometers. The limits of the vertical y-axis, which is right here, will range from 0 to 250,000 days. Then we will label each point with the name of the planet. Note, the terrestrial planets will be plotted close together and they will be labeled as a group. Now, let's continue. Okay, so to begin, we are going to, let's move this so you can see. Okay, so we are going to be labeling our axes. So our horizontal axes, which is the x-axis, is going to range from 0 to 12,000 million kilometers. So what that's going to look like is we are going to go, this will be 1,000. This will be 2,000. This will be 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000, 11,000, and 12,000. Now we always want to label. Let's make sure you can see that. So we always want to label our axes. So since this is the x-axis, this is going to be, we will go ahead and label it. Let's do distance from sun. Sun, and then we always want to put the scale that we are using. So this is going to be in million kilometers, just so that we know. Okay, moving on to the y-axis. So this is going to range from 0 to 250,000 days. Okay, so I've already labeled the x-axis with the right scale, and we have labeled it distance from the sun in million kilometers. So it's ranging from 0 to 12,000. That's our range. And then I've done a rough sketch of labeling the y-axis, which is going to be the orbit duration in days. It's going to be ranging from 0 to 250,000 days. So the best way to get that, let's make sure you guys can see what I'm doing. Okay, so the best scale to get that is going to be going by 12,500. So right here, we actually will label it this way. So right here is going to be 12,500. Then we're going to keep on going until we get to 250,000. So now we have 25,000, 37,500, then we have 50,000, and then we have 62,500. Little tight on space here, but doing the best we can. $225,000 and 250,000 days. Whew. Okay, then let's go ahead and erase pencil marks below just so that we can see it a little bit more clearly. Okay, and then I'm going to put the label right up here, if you can see that, just because we ran out of room. Actually, I'll go ahead and I'll label it using this paper underneath just so that you can see better. So this is the y-axis and this is going to be the, like I said, orbit duration around the sun. Let's fix this. And we always want to put the range or the scale. So that is in Earth days. Okay. Make sure you can see all of that. Perfect. Okay, so now what we're going to do is we are going to plot the points. So I have my data table pulled up next to me. And we're going to be graphing. We're going to be plotting the points. So let's start off with Mercury. So Mercury, the distance from the sun is 57.9 million kilometers. So remember, this is in millions, so this is going to be way over here. And its orbit duration is 87.96 Earth days. So that's also going to be way down here. So we're just gonna put this right about here, just an estimate because it's hard to get an exact one. So then this is Mercury. I'll get a different color pen so we can see it clearly. Oops. So that's Mercury. Now let's move on to Venus. Venus is 108.2 million kilometers. away from the sun, and its orbit duration is 224.68 days. So that's also going to be roughly around here. Let's put her, she's further here, so we're gonna go ahead and put her right about here. Label. And now let's do Earth. Earth is 149.6 million kilometers away from the sun, and it takes roughly 365.26 days. So just gonna be a little bit further. We're gonna put this right about go about here. And then label it Earth. And Mars. So Mars is 227.9 million kilometers. So that's gonna be, we'll put that right there. And 686.98. So let's even bring this further. This is Earth, or I'm sorry, this is Mars. And then we're going to do Jupiter, which is 778.3 million kilometers. So that's way closer over here. And it is 4,329.6. So we're gonna put that over here. And that is going to be Jupiter. Now these are all the terrestrial planets, so it's a little hard to see because they are all super close together, but that's okay. So Saturn is 1,427 million kilometers away from the sun. So that's going to be over here. And it is 10,000. So sorry. And it is 10,751.44 Earth days to orbit. So we are going to go, let's say around here will be roughly 1,427, and then 10,000 is going to be way up here. Now don't worry if it's hard to see, I can still see, and we will put the mark of a smooth line. So this is Saturn. Okay. Now moving on to Uranus, and that is 2,871 million kilometers. So now we're all the way back over roughly around here, and we're going all the way up to 30,685.55 orbit duration days. So big jump. And that's going to be around, we'll say here. Now this is going to be Uranus. Now we move on to Neptune. So Neptune is 4,497.1 million kilometers. So we're going to be all the way roughly right here. And it is 60,155.65 Earth days. So we're going all the way up to 60,000. Go up here. Estimate right here. This is going to be Neptune. Make sure we're still in focus. And now as you can see right here, they are very, very close together. So it is going to definitely need that smooth line. Okay, so now we're going to draw a smooth curved line through the data. So I'm going to get my black pen right here that I used before, and we're going to draw a smooth line through all of these points. So, boom. Boom. So that's as smooth as we can get it as of right now. And now we will be continuing on to the latter portion of this lab. Okay, so I have gone ahead and calculated the estimated orbit duration in Earth days for Pluto, Ceres, and Iris. Now, these had to be converted, which is where I used my calculator. It was a little difficult to use both on camera, but now what we're going to do is we're going to do the exact same thing that we did for the other planets. So after you log this all into the data, which I have already done so, we are going to plot the distances. So Pluto is 5,906.4 million kilometers away from the sun. So we are going to go to almost 6,000, and its estimated orbit duration is 90,410.5 days. So we're gonna go all the way up to around here. We are going to use a different color, and we are going to label this Pluto. All right, moving on. Ceres is 414, so way back here, million kilometers. But it takes 1,682 days. So this is gonna be like way over here. And this is going to be Ceres. And Iris. Iris is the largest, so we're going to go all the way over to 10,172.8. And mind you, this is just a rough estimate. And let's go right around here. And we're going to go all the way up to 203,670 days. So let's go all the way up. Not quite. We're going to go down here. And she'll land right about here, give or take. Make sure I'm in frame so you can see what I'm doing. And like I said, this is Iris. Now, after I have placed all of that data into data table 2, we're going to take a photo of this completed graph. If it'll focus, answer the following questions, and we will be done with the lab. Thank you for tuning in.